Hi, welcome back. Today I'm glad to show you a tool that I've just finished. It's a coordination study tool that helps coordinating overcurrent relays on a typical step-down transformer that you can see shown here. That transformer is a 400 MVA transformer with a high side of 132 kV and a low voltage side 11 kV. CT ratios are shown here with 200 to 1 on the high side and 2000 to 1 on the low side. The impedance of the transformer is 8%. So these are the values that I'll be using as a default, but you can change all these values as you can see on the table on the right hand side. Here, for example, if you want to change the transformer back, I don't know, to 50 MVA, you can do it here, and then it'll be reflected on the single line diagram. And the same thing here for all the other values that I'll go through later on in this presentation. So for a low side on the bus 11 kV side fault, what are the coordination studies that need to be applied on this in this case? This tool is a way to show the curves that the curves are displayed. They are color coded, so the yellow is for the LV side, whereas the green here is for the HV side. On the left hand side here, you've got the typical values, the standard here, the standard that is selected is the IEEE. On the HV side, you've got the curve type, which is extremely inverse right now, the pickup value, the time dial, or the time setting multiplier, depending on the standard. You've got the formula that is representing this standard. So the same thing for the low voltage side. Here you've got a typical plot of an inverse characteristic with the time on the ordinate in seconds and the horizontal with the amperes. So just to show you the flexibility of this tool, you can switch from standards to standards. So let's go, by clicking you will be cycling through the typical standards. For here we're going from IEEE to the next one, which is the IEC, right? So the IEC, US curves, you've got the UK curve, you've got the Schwier curves here. So for example, if we take the Schwier curves, if you go on the drop down menu here, you'll see the typical 5 curves that you have on a overcurrent Schwier relay. So for example, if you select cell U5, you'll see that the graph is updating accordingly. Let's go to IEEE, for example. Same thing, you've got a menu, you can go on extremely inverse. So you see these things update automatically. You can change as well the pickup value. Let's put that to 3000 amperes on the high side. Right, so you see that it's dynamically updating. For your information, you've got the view curves constants here that you can click on. You will have a summary of the value, the constants that you have on the equations that you can see here, highlighted in green and yellow, right? So what you can do is dynamically change the time dial. For example, on the HV curve, if I want to increase, you can drag the slider here and it will update automatically here on the right hand side. What I've done as well is something that I've always wished to be a feature on these overcurrent coordination things is, as you can see, as I hover above the curve, there's a cross here that signals that you can drag and drop the curve to where you want it to be. So, and then that will be reflected on the pickup here. If you drag and then control, you are able as well to change the time multiplier setting as well. So that just adds a little bit of flexibility in using this tool. So these are just for the sake of playing with the curves and see how they are, comparing to each other, so that you can have an understanding on where your setting studies ought to be and avoid any malfunctioning. So on the right hand side, what I did is a calculate button that allows you to take these values that you have here on the right hand side that correspond to the single line diagram. And okay, so if we press on this, you will see that you have all the load, the primary and secondary fault current, and the time setting multiplier for the LV and HV side. Here, these values and these curves are corresponding to trip times on the LV and HV side that are basically governed, as it were, by these times. So here we've got 0.8 seconds for the HV side and 0.6 on the LV side. So if you look at this logarithmic graph, you can locate where the 0.6 and 0.8 are, and you can see that there's these 200 milliseconds time gap for these faults that you can see here, right? So this is a tool that obviously is for educational purposes, but you can make quite a bit of insightful calculation, and it can be applied to a typical single line diagram like this, right? So there's plenty of other things that I'd like to develop, and just to give better insight on how to coordinate these overcurrent relays, right? So this is just a short presentation. I haven't put it online yet on my website, but I plan to do it as soon as I finish this video, so that you can have a play with it and let me know what you have as comment and suggestions. So let me know, and I appreciate it, taking the time to view this presentation. Take care, and talk to you later. Bye.